Prep. I am Deepak Mishra and we are discussing here NIELIT important question. As everyone know, NIELIT का exam 4th of November को होने वाला है. I think everyone is motivated and please keep hard work for your examination. So in this class, my dear friend, I will try to discuss some problems like which already asked in NIELIT exam, and I will try to take some other questions also. And if you observe carefully, like of NIELIT examination, my dear friend, they have asked mostly gate questions, fine, and gate 1 mark question. So basically they will ask very easy question, straightforward question, fine. Question are not complex, fine. Question are easy only. It will not moderate also, fine. If you are good with the basic concepts, you are able to solve any problem, fine, any problem. So let me start with the start the session, fine. I think hope everyone is ready. So I'm starting now. So yeah, this is my Telegram link, my dear friend. So if you have any doubt regarding any question, let's suppose if if you have any problem regarding any question, you can ask me in this group, and I can share the PDF also, some questions for the practice for NIELIT exam. I will share here also. And yes, for daily important questions and notifications, for the notifications also, you can join this Telegram link. Okay. So yeah. So let me ask this question. This question like already came in NIELIT exam, and this question from DBMS. It is quite easy question. Please try once, then I will explain. Try once. Okay. So see clearly, definitely one question will come, 1 or 2 question you will see from the normalization, fine. Maybe they will give the FD and they will ask what is the highest normal form, or maybe they will ask you like whether the decomposition is lossless or lossy, or maybe dependency preserving also, fine. Or maybe they will ask some theory question based on FDs, fine, FDs or normal form. So you should be very ready. You should be very careful because you cannot lose marks here. Fine. Normalization is a very important and very easy topic. And definitely if your concept is clear, you are able to solve the problem. You are able to solve the problem. So I'm waiting for the reply. Please try this question, my dear friend, and please let me know. Everyone. Please reply. What is the answer for this one? This is very easy question. Okay, let me try here. Which of the following statement is not correct? They are asking, not correct. Which of the following statement are not correct? They are telling here, S1 statement, 3NF decomposition is always lossless join and dependency preserving. So 3NF, they are telling you 3NF क्या होता है? हमेशा lossless join होता है और dependency preserving होता है. That is true. Already we have discussed in the DBMS class, fine, on the YouTube. Also, fine, we have discussed this one. So 3NF decomposition is always lossless join and dependency preserving. Okay. 3NF decomposition is always lossless join, but may or may not dependency preserving. This is false, my dear friend. This is false. This is absolutely false. 3NF is always dependent. 3NF is always what? Lossless and dependency preserving. So that's why just option is what? False. What about this one? BCNF decomposition are always lossless join and dependency preserving. So this is false. Yes, we have seen already BCNF, it is lossless join, but it may or may not dependency preserving. It may or may not dependency preserving. Okay. So this is false. BCNF decomposition is always lossless join, but may or may not dependency preserving. Yes, this is true. This is true, my dear friend. If you remember, already I told you, let's suppose this is a normal form, first NF, second NF, fine, third NF, and BCNF, and BCNF. If you talk about the redundancy, 0% redundancy I'm telling here, or let me write here, let me remove this one. Or you can say like, so 0% redundancy, you can write like this also, no problem, redundancy. So in first normal form, no, we don't have redundancy, like we have redundancy in first normal form, my dear friend. Why? In first normal form, see, the design goal of RDBMS is to convert into the first normal form, not to minimize the redundancy. Are you getting my point? What is first normal form? I think everyone knows. Every column should contain single value, my dear friend. Okay. So in first normal form, we don't have 0% redundancy. If someone asks you, because we have a redundancy in first normal form. We have a redundancy in second normal form in terms of partial dependency. Fine. We have a redundancy in third normal form in terms of transitive dependency. Maybe they will ask this one. This keyword is very, very important. But in BCNF, we have 0% redundancy. We have 0% redundancy over single value FD. If it is multi-valued FD, in BCNF also there will not be a 0% redundancy. Once again, I'm repeating, my dear friend. See, everyone know, my dear friend, trivial FD does not cause any problem. Only non-trivial FD will cause the problem. If someone asks in first normal form, is there any redundancy? Answer is yes. You can say yes. I am telling here, see, is a first normal form, is there 0% redundancy? No. That's why I'm writing here cross. Fine. That's why I'm writing here cross. In second normal form, can we have 0% redundancy? No, we don't have 0% redundancy because we have a redundancy in terms of partial dependency. Partial dependency. I think everyone know what is partial dependency. Third normal form, we have redundancy in terms of transitive dependency. In terms of transitive dependency. In BCNF, my dear friend, we have 0% redundancy because left hand side is a super key. Fine. That's why you can say in BCNF we have 0% redundancy. Now, if you talk about lossless, my dear friend, see, all decomposition should be lossless. Lossless, my dear friend. See, so first NF, second NF, third NF, BCNF, all are lossless only. All are lossless only. And if you talk about dependency preserving, my dear friend, dependency preserving. So first NF is dependency preserving, second NF is dependency preserving, third NF is dependency preserving. BCNF may or may not dependency preserving. BCNF may or may not dependency preserving. So BCNF हो भी सकता है dependency preserving, BCNF नहीं भी हो सकता है. Fine. That's why I have written cross here. May or may not. Fine. May or may not means false. So it is very easy question, but definitely one question will come from normalization. You should be very good practice on the normalization question. Maybe they will give you some FD and they will ask you what is the highest normal form. Fine. Or maybe they will ask you, like they will tell you it is not in second normal form, like in how many minimum table you can decompose, so that you can decompose, it will get into the second normal form. Fine. Maybe they will ask like this also. Fine. So you should be ready with this. Fine. If you have any doubt, you can ask me. Okay. So answer for this one is nothing but, my dear friend, true. They are not correct. They are asking. So not correct is nothing but S2 and S3. So S2 and S3, my dear friend, I think D for Delhi is the right answer. देखो, NIELIT का एग्जाम आसान होता है, 3 घंटे का एग्जाम होता है, 180 मिनट्स आपके पास होते हैं. ठीक है. मेन मुद्दा क्या है यहाँ पे क्वेश्चंस कराने का? मेन मुद्दा क्या है? मेन फोकस क्या है? समटाइम यू आर इन हरी. फाइन. आप बहुत ज्यादा जल्दी में होते हैं, वो बहुत इजी क्वेश्चन मिल गया. Fine, you are not reading properly also, not correct. Fine, not correct. And you will give the wrong answer. थोड़ा सा concentration lag होता है आपका एग्जाम में और आप गलत कर देते हैं. तो आपको ये easy क्वेश्चन तो बिल्कुल गलत नहीं करते हैं ना, ये तो पाप हो जाएगा, sin हो जाएगा. Fine, you should be concentrated. ठीक है, आपको concentrated होना है. This class only for like you should see in like they will not ask rocket science. Very easy question they will ask. Fine, very easy question. Label of questions are very easy. It is not tough. Fine. Because 60 questions you can say for aptitude and quant and 60 question for your technical subject. So 3 hours are there. So you should be balance your time. Like कितना time आपको quant या aptitude में reasoning में देना है, कितना आपको technical में देना है. Fine. You should be very careful. And sometime what happened, they will give you some like calculation based questions also. Fine. So you should be very careful. Okay. This question from compiler, because I have mixed up the subject, because like in exam also they will not ask you serially DBMS question followed by CD question. So yeah, you can try this. Which of the following is a machine independent optimization? Machine independent optimization. So we have two type of optimization we have seen in the compiler class. We have machine independent and machine dependent. Fine. So in machine independent, my dear friend, I think can anyone tell? Please reply. So in machine independent, my dear friend, yes, loop optimization. It is nothing but machine independent. We have seen in loop optimization, we have seen loop unrolling, fine, and we have seen loop unrolling, loop jamming, fine, and we have seen induction variable, fine, loop invariant, fine, all kinds of loop optimization we have seen, and this is nothing but machine independent optimization. So redundancy elimination is also what? It is also what? Machine independent optimization. I think you know. Folding. Constant folding, you can say, constant folding or constant propagation. It is nothing but also, it is machine independent optimization. So answer will be what? All of these. सो सच टाइप ऑफ क्वेश्चन कैसे आपको याद रहेंगे जब आपने बेसिक कॉन्सेप्ट्स पढ़े हुए हैं. फाइन, बिकॉज दे विल आस्क दिस ओनली, दिस काइंड ऑफ क्वेश्चन दे विल आस्क. दे विल नॉट आस्क वेरी टफ क्वेश्चन. वंस अगेन आई एम टेलिंग माय डियर फ्रेंड, if you know the basic thing, what is machine independent, what is machine dependent, you are ready to give the answer. Fine, you are definitely, you will give the correct answer. So see, all types are here, A, B, C, all types are here is nothing but, all types are is nothing but, my dear friend, machine independent optimization. Okay, now this question from operating system, my dear friend, very simple question. Fine, bacha problem it is. If a processor has 32-bit virtual address or logical address, both are same. 28-bit physical address, 28-bit physical address, fine, physical address, 2 KB pages, how many bits are required for the virtual physical page number? Fine, how many bits are required for virtual physical page number? Fine, can you please tell me what is the answer for this one, everyone? What is the answer for this one? Can you please reply? Everyone, please reply. I am waiting for the answer. Okay, I think option is visible now. Can you please give me in the chat box? This is very easy question. Everyone knows CPU always generate logical address in the form of P and D. Fine. So they have given here logical address, 32-bit logical address, means logical address space will be 2 to the power 32, and they have given 28-bit virtual address, physical address, it is nothing but 2 to the power 28 PAS. Fine. Okay, can you please tell me how many bits are required for the virtual physical page number? Okay, Save is telling B. Yeah, anyone else? Yeah, this is very easy question. Such type of question will come in the exam. Fine. This is NIELIT question only. Fine. Okay, so B is the correct answer. Yes, B is the correct one. See, clearly they have given 32-bit virtual address. It is nothing but 2 to the power 32. Fine. And they're asking how many bits are required for the virtual physical page number. Page number, my dear friend. It is nothing but 2 to the power 32. Divide by what? Can you please tell me? Divide by what? The page size is nothing but 2 KB means 2 into 2 to the power 10. It is nothing but 2 to the power 32 minus what we have 2 to the power 11. So it is nothing but 2 to the power 21. So how many bits are required? 21 bits are required. 21 bits are required. Fine. Everyone know. Everyone know. Okay. Fine. Now what about this one? Next one. 28-bit for 28-bit physical address. So it is nothing but 2 to the power 28. Page size and frame size is same only. Divided by 2 to the power 11, it is nothing but 2 to the power 28 minus 11. It is nothing but 2 to the power 7, and this is nothing but 1. So 17 bits are required. So 21 and 17 is the right answer for this one. Fine. 21 and 17 is the answer for this one. Okay. Everyone know, like, number of pages in LAS divided by what? It is nothing but, see, LAS divided by what? Page size. Fine. So what is LAS? 2 to the power 32 divided by what? 2 to the power 11. It is nothing but 2 to the power 21. So how many bits are required? 21 bits are required. For frame also, you can find out. Fine. Okay. Can you please tell me? So number of pages and number of frames you can find out. Okay. Because page number is equal to what? Frame number. Page size equal to what? Frame size. Okay. Now, can you please tell me, what about this one? The number of edges in the regular graph of degree D and n vertices is. What is the answer for this one? Can you please reply? Everyone, please reply. So see, we have today class, आज class है, फिर tomorrow is gap, fine. Then we have a class on Thursday and Friday. Saturday, Sunday we don't have any class. Then Monday will come, Monday, Tuesday and Wednesday. Fine. So yeah. Please try to give the correct answer for this one. The number of the edges in the regular graph of degree D and n vertices is. They are talking about regular graph. Okay, someone telling C. Anyone else? So regular graph, I think everyone know. Regular graph. See this one. This is nothing but 2-degree regular graph. Because see, regular graph is nothing but, see, my dear friend. Sir, take class on DSA also. Venkat, I think DSA is already taken by Satya sir. You can join on 7 p.m. evening. Fine. Satya sir will take DSA. Fine. See clearly here. So I'm taking right now, my dear friend. I'm taking NIELIT important question series, like mix of questions. Maybe data structure questions also will be there. Fine. You can try to solve the question. And if you want to join DSA class, you can join on 7 p.m. Satya sir is taking the class. Okay. So see clearly, regular graph means, I think everyone know, degree of every vertex is same. Degree of every vertex is same. Fine. See, this is what 2-degree regular graph. This is also what 2-degree regular graph. 2-degree regular graph. Are you getting my point? So see, they are telling here the number of edges in regular graph of degree D and n vertices is. They are asking about the number of edges. So everyone know first theorem of the graph theory. This question will come in your exam, my dear friend. Discrete mathematics के अंदर graph theory syllabus है. Discrete maths में graph theory है. ये NIELIT का ही question है. This question already came in NIELIT exam. Discrete mathematics अगर syllabus में है तो उसमें graph theory is the part of it. Fine. So definitely they will ask question from here. Okay. Definitely they will ask question from here. Even though graph theory is your portion of algorithm also. Fine. Algorithm also. So yeah. Is that clear? ये NIELIT 2017 या 2016 का क्वेश्चन है. If I am not wrong, you can cross check. So everyone know, my dear friend, everyone know what is the first theorem of graph theory. Sum of degree of vertices sum of degree of vertices is equal to what? 2 into number of edges. 2 into number of edges. Sum of degree of vertices is equal to what? 2 into number of edges. Everyone know. So can you please tell me? See, degree, regular graph of degree is what? D. So degree is D. Fine, degree is D, my dear friend. And n vertices. So n into D equal to what? 2 into E. 2 into E. This is nothing but first theorem of graph theory. But this year discrete mention is not mentioned in the syllabus. Okay, they have clearly not mentioned discrete mathematics. But still it is important. Fine. Okay, we'll try to solve this question. Fine, and we'll see also like whether fine. So what is happening here? ND equal to 2 into E. What is E here? E here ND by 2. This is very simple question. So this question is based on my dear friend graph theory. Fine, and you know first theorem of graph theory. Sum of degree of vertices equal to 2 into number of edges. So total we have n vertex and degree of every vertex is D. It is nothing but n into D equal to what? 2 into number of edges. So edges equal to ND by 2. ND by 2. So D for Delhi is the correct answer for this one. D for Delhi is the correct option. Okay. Now, can you please try this question? Consider an null tree, context-free grammar. If for every pair of production A goes to U and A goes to V, they have given some option. Can you please try to give the answer? Okay, only probability and combinatorics. Okay, so we'll skip some graph theory questions. Fine. They have already asked in NIELIT exam, so we can skip if you want. Okay. Can you please try this question? This is question from compiler. Fine. I think compiler is in syllabus, so you can try this one. What is the answer for this one? Please reply. Okay, so I am trying this. See, clearly they have given some production A goes to U and A goes to V, and they are telling here if first of U and intersection first of V is empty, then the CFG has to be LL1. CFG has to what? LL1. See clearly here. So in CFG, what we will see? We will see the prefix of the grammar. Fine, we'll check. Fine, see clearly. Let me write some grammar. S goes to A oblique A comma B. Is it LL1? Is it LL1, my dear friend? No, it is not LL1. See, A is common here. A is common here, so it is not LL1. So what we do, we find first of this one and first of this one. If intersection is phi, you can say it is LL1. If intersection is not equal to phi, you can say it is not LL1. So if you do intersection A, intersection AB, what is the answer? Answer is A. If it is A, if it is common, my dear friend, you can say it is not LL1. It is not LL1. So this grammar is not LL1. Or you can check what I told, like first of this one, oblique first of this one. See, A goes to U oblique V. So A goes to U oblique V. So what is U intersection V? Phi only. Intersection is what? Disjoint set. Phi only. So if it is phi, my dear friend, if it is empty, then definitely you can say the grammar is what? LL1. LL1, my dear friend. So the meaning of LL1, I think you know. Leftmost derivation, scan left to right and leftmost derivation, and this is nothing but one input at a time. One input at a time. Fine. Fine. I think you know this one. Top-down parser ka hi part hota hai LL1. It is the part of top-down parser, my dear friend. So this grammar is what? This grammar is what? Not LL1. But can this grammar is LL2? Maybe they will ask you. Is this grammar is LL2? This grammar is LL2 actually. LL2. LL2 means, my dear friend, see whether two input is common or not. Two input is common or not. See, this is A and this is AB. So two input is not common. So you can say this grammar is LL2. And if it is LL2, it is LL3 also, LL4 also, LLK also. But this is not LL1. As of now, I am talking about LL1 only. So LL1 में क्या करना है? पहला input देखना है. If first input is common, first input means first terminal. It should be terminal. Fine. अगर terminal नहीं है तो उसका first निकालना होगा. First of terminal is terminal only. So this is A and this is A. A is common. If A is common, my dear friend, it is not LL1. It is not LL1. It is LL2. It is LL3 also. Because in LL2, we'll check two input. Fine. Combinedly two input. So this is LL2. If it is LL2, it is LL3 and so on. It is LLK. No problem. Okay. Now the second one, if the CFG is LL1, then first of U intersection, first of V has to be empty. Has to be empty, my dear friend. Okay. So if the CFG is LL1, then first of U and first of V has to be empty. Is this correct? Is this correct, my dear friend? Yes, this is also correct. B is also correct. They are telling, actually this is by implication. No? This is by implication. If it is LL1, my dear friend, definitely, see, if common is what? Common is equal to phi, definitely it is LL1. I think you know discrete mathematics. This is nothing but, if you say this is nothing but P. This is P. So this is P and this is nothing but CFG has to be LL1. You can say Q. There is nothing but P implies Q. P implies Q. And this one is nothing but they are telling here Q implies P. Q implies P. So my dear friend, actually it is by implication. It is by implication. If it is LL1, my dear friend, definitely, if it is LL1, your grammar is LL1. First of U and first of V has to be an empty, my dear friend. Has to be an empty. Fine. First of U and first of V has to be an empty. Or you can say first of U and first of V is empty, then the grammar is LL1. Yeah, both are correct only. So A is also right, B is also right. So yeah, C is the right answer for this one. So answer is what? C. C for Chennai is the right answer, Shiv. Iska answer C hoga, na hi A hoga. Is that correct? Please reply. Is that correct? Fine. So this is by implication. कोई आपसे पूछता है देखो grammar अगर LL1 है, if it is LL1, definitely my dear friend, first of U and first of V equal to phi, or first of U intersection first of V phi है, then the grammar will be LL1. Okay. Now I'm moving to the next question. Given relation R, WX and SYZ, the result of select distinct WX from R, S. R, S. What is the answer? R has no duplicates and S is non-empty. R and S have no duplicates. S has no duplicates and R is non-empty. And R and S have the same number of tuples. Can you please try this question? Everyone please try and please try to give the correct answer. What is the answer for this one? Everyone please reply. Okay, this question is also from GATE and they have asked in NIELIT also. Fine. So see clearly, given relation R, WX and SYZ, the result of select distinct W, X from R, X. Fine. So R has no duplicates and S is non-empty. I think fine, and R and S have no duplicates, and S, I think this question might be, let me check, this question might be incomplete. Okay, see, is guaranteed to be, see, is guaranteed to be same as R. Same as R. Fine, in this question they have asked actually, fine. See, they have given this query here, select distinct W, X from R, X, R, S, and they are telling here is guaranteed to be same as R. Fine. See, this is very easy question. So they are telling R has no duplicates and S is non-empty. In the second question, they are telling R and S have no duplicates. In third one, they are telling S has no duplicates, but R is non-empty. And the fourth one, they are telling R and S has the same number of tuples. Okay, let me try here. And they are telling the output of this one is nothing but it is to guaranteed to be same as R. The result will be R only. So everyone knows, see, select distinct. What is the meaning? I think you know, see clearly here. So let me write the query here. I think it is visible here. So I'm writing here. Let me write here. Select distinct W, X from R, S. So everyone know, my dear friend, everyone know the execution will be start from. So first I will go here. I will do the cross product. There is no where condition here. Fine, I will do the cross product. Then I will select it, and then finally I will remove the duplicate tuples. Fine, I will remove the duplicate tuples. So my dear friend, they want, my dear friend, the result will be same as R, my dear friend. So if R has no duplicate and S is non-empty. So let me try here. R has no duplicate. Let me try here. R has no duplicate and S is non-empty. Let me write here. Like here we have, let's suppose 1, 2, and here what we have 1, 3. And my dear friend, S I am taking something, let's suppose A and B, whatever, A and B. So if you do this, what is happening here? See, you do R cross S, and what you find, my dear friend, select distinct W, X. So this is nothing but W, X, and this is nothing but Y and Z. Let me take Y and Z also. A1 and B2, no problem. So what they want actually, they want only WX. See clearly, they want WX. They want R only. They don't want S. So you know, so if you select distinct, my dear friend, 1, 2 and 1, 3 will come. Definitely 1, 2 and 1, 3 will come in the result. 1, 2 and 1, 3 will become in the result. But if we'll take R as a duplicate, let's suppose I will take 1, 2 also here. 1, 2. So what will happen, my dear friend? I think you know. Then if you select distinct, my dear friend, only this 2 tuple will come. It will not come as same as R. It will not come as same as R. वो R की तरह same result नहीं आएगा, because अगर आपने let's suppose R के अंदर अगर आपने duplicate record entry कर लिया, let's suppose 1, 2, 1, 3 और 1, 2 होता, and you select distinct W, X, the answer will be 1, 2 and 1, 3. 1, 2 and 1, 3. But they are asking actually, the answer should be is guaranteed to be same as R. Same as R. So same as R कब आएगा? जब R को duplicate नहीं होगा. जब R duplicate नहीं होगा. जब R duplicate नहीं होगा, so what it will select? It will select distinct tuples. 1, 2 and 1, 3 are distinct only. So it will what? The same as R. It will print. No problem. Fine. So that's why R should be no duplicate. And S is not empty. See clearly. If you take S is empty, what will happen? I think you know. See clearly, the meaning of R cross S is nothing but R, S is nothing but R cross S. If S is empty, my dear friend, R cross S will be empty. So S should be not empty. S should be not empty. So that's why A is the right answer for this one. A for Ahmedabad is the correct option for this one. A for Ahmedabad is the correct option. Is that clear, everyone? Please reply. Everyone, please reply. Is that correct? I'm waiting for your response. So the answer will be what? A for Ahmedabad. A, R has no duplicate and S is not empty. I told you very clearly in the class, see clearly, if R has, let's suppose M tuple and S have N tuple, my dear friend, total we have M cross N tuples. M cross N tuple in what? R cross S. But let's suppose if R have M tuples but S have no tuples, like empty. So the result will be empty only. Fine. So it should be not empty. It should be what? Not empty. Okay, I'm moving now. I think it is clear. So This is question for ER model. So ER model uses this symbol to represent weak entity set. Weak entity set, I think everyone know. See, dotted rectangle. First one option, dotted rectangle, diamond, double outline rectangle, or none of the above. None of the above. So weak entity set, my dear friend. Weak entity set. Double outline rectangle. Yes, C is the right answer. Double outline rectangle. Fine. So this is the strong entity set. Fine. And this is what weak entity set, my dear friend. Weak entity set. Fine. And in weak entity set, I think everyone know the relationship should be what? Total participation, and the relationship will be identifying relationship. It should be also in double diamond, and this is nothing but your strong entity set. And in strong entity set, we have some attribute. Let's suppose this is EID. Fine. Here what we have? We have partial key. We have what? Partial key. Everyone know partial key. Is that clear? You should know about this one. See, this should be what? This should be what, my dear friend? Double rectangle, the weak entity set. And the relationship, what? It will be identifying relationship. And it is what? Nothing but, my dear friend, it is nothing but, can you please tell me? It is nothing but total participation. And this relation should be one to many. You should remember this one. Already I have covered in the lectures. If you want, you can watch my lecture. Fine. So double outline rectangle. Answer is what? C. C for Chennai. Okay. Which of the following algorithms solve all pair shortest path problem? Can you please tell me what is the answer for this one? All pair shortest path problem. All pair shortest path problem. What is the answer for this one? Yeah. So this one is nothing but Floyd-Warshall algorithm. Yes, this is Floyd-Warshall algorithm. All pair shortest path problem. This is nothing but single source shortest path problem. Discussed algorithm is nothing but single source. Fine. Single source shortest path problem. Okay. And this is nothing but all pair shortest path problem. Fine. And I think you know Prim's algorithm. This is nothing but from minimum spanning tree, and this one is also what? Minimum spanning tree. Fine. And yeah, might be they will ask about this one also, my dear friend. Discussed algorithm is what? It is greedy or dynamic. Discussed algorithm. It is greedy or dynamic. Floyd-Warshall. It is greedy or dynamic. Maybe they will ask. Prim's is greedy or dynamic. Kruskal is greedy or dynamic. Can you please tell me? What about Prim's algorithm? It comes under greedy or dynamic algorithm. So Prim's Kruskal, it is nothing but greedy. This is what? Greedy. Greedy? Fine. Greedy. What about Dicastra and Floyd-Warshall? What about Dicastra and Floyd-Warshall? Dicastra is also greedy. Fine. And what about Floyd-Warshall? Floyd-Warshall is what? Dynamic. Fine. Is that clear? Floyd-Warshall is what? Dynamic. Am I right? Please reply. So they will ask you the algorithms, not algorithm actually, they will ask the complexity also. You should know the complexity of each and every algorithm. So is Dicastra algorithm is failed for negative weight? Is Dicastra algorithm is failed for negative weight, my dear friend? Can you please tell me? Yes, Dicastra algorithm may or may not fail. Sometime it fails, sometime it not fail. That's why you can say yes, no will be the answer. Fine. So Dicastra algorithm will be failed for negative and negative weight. Fine. Negative and negative weight. Fine. I think you know the algorithm. I'm not telling the algorithm here. Might be they will ask like in Prim's algorithm, you know, everyone know like will not get disconnected graph. Will always get connected graph. In Kruskal's algorithm, we will get disconnected graph. So might be they will ask you like, can we able to apply Prim's algorithm if we have disconnected graph? Can you please tell me? अगर हमारे पास अगर disconnected graph है, क्या उसके ऊपर हम Prim's algorithm लगा सकते हैं? Can we able to apply Prim's algorithm? If the graph is disconnected, it means it have more than one component. No, you cannot actually. You cannot. हम उस पे Prim's algorithm नहीं लगा सकते. Prim's algorithm नहीं लगा सकते. But we can apply Kruskal algorithm. बट वी कैन अप्लाई क्रुस्कल्स एल्गोरिथम. क्रुस्कल के अंदर हमें डिस्कनेक्टेड ग्राफ मिल सकता है. फाइन, इज दैट क्लियर? आई थिंक यू नो हम सबसे जो भी सबसे मिनिमम वेट होता है उसको उन एज को उस एज को लेंगे, फिर उसके बाद जो दूसरी एज होगी वो जो मिनिमम होगी उसको लेंगे. सो इट मे बी डिस्कनेक्टेड. फाइन, बट इन प्रिम्स वी कैन टेक एडजेसेंट एजेस ओनली. फाइन. So I think everyone know the concept, but yeah, they will ask in the exam. You should be very careful. Now, can you please tell me? Assume transaction A holds a shared lock R. If transaction B also requests a shared lock R, it will. This is also a NIELIT question. Can you please tell me what is the answer? Very basic question. They will ask only basic thing only. Fine. Please be careful while solving the question. Please be careful. What is the answer for this one? So they are telling here, see, assume a transaction A holds a shared lock R. If transaction B also requests a shared lock on R, it will immediately granted. Shared lock immediately granted, my dear friend, no problem. Fine. But if it is exclusive, it will not be granted. Fine. It is exclusive, it will not be granted. I think everyone knows. Fine. Let's suppose shared. So it will not granted. If it is exclusive, not granted. If it is exclusive and shared, not granted, not granted. Fine. This is the lock compatibility table. Fine. This is the lock compatibility table. Okay. Okay. Can you please try this one question? This question is also easy one. Can you please try this question? This question for disk scheduling. Fine. From operating system. Can you please able to give the correct answer for this one? So in the question they have, see, this is all about calculation. Fine. So please try to do it. Fine. And it is quite easy. So in the question they have given disk request come to a disk driver for cylinders in the order 10, 22, 22, 46 and 38 at the time when the disk drive is reading from cylinder 20. The seek time is 6 millisecond per cylinder. The total seek time if the disk arm scheduling algorithm is first come first serve. First come first serve. Fine. So directly you can try. See here. So yeah. So it will start. Where it will start, my dear friend? Can you please tell me? At 20. So start from 20. So from 20 it will go to 10. Okay. It will go to 10. And from 10 it will go to 20, 22, 22. And 22 to it will go to 20. Okay. 20. And then 20 to 2. So it will go to 2. 2. And 2 to 40. It will go to 40. 40. And 40 to 6. This is nothing but 40. 40 to 6. So let's suppose it is 6. And 6 to 38. So it is 38. And we have 38 only? Yes, we have 38. No problem. So just see clearly here. So it is nothing but, let me just change the color or let me write here. This is nothing but 10. This is nothing but 12. And this is nothing but 20. And yeah, this is nothing but 38. And this is nothing but 34. And this is nothing but 32. 32. Just add it. So what we have, can you add 10, 12, 20, 38, 34, 32. So what we have? We have 8 to 10, 8 to 10, 4, 14 to 16, 6, and 3 is 9, 9 to 11, 11 to 13, 114, I think. It's 146. It's 146. Can you please 4 to 8, 8, 16, 4 to 6, 6 to 8 at 16, yes. 16 and 3, 9, 3, 12 to 13, 3, 9, 3, 12 to 14 to 16, 117, 176. 176. Fine. And my dear friends, see clearly, in the question they have given the seek time is 6 milliseconds per cylinder. So I think 176 into 6. So answer will be what? 176 into 6. So answer will be, if we calculate 6, 6 are 36. And 6, 7 are 42. So 45. 6, 7 are 42. 45. Am I right? And 6, 1 are 6, 14. I think we have done something wrong. Can you please cross check? So we have 20, 20 to 10, 10 to 22, 12, 22 to 20. Okay. 22 to 20, it will come 21st. It will come 21st. And 22, this will be 18, my dear friend. This will be 18, okay? 22, 2, fine. 2 and 2 to 40, and 40 to 6, and 6 to 38. 6 to 38, fine. 6 to 38. Now it is fine. I think we have done mistake here. Calculation mistake we have done here. See, this should be what? This should be 2. Fine. And this should be what? 20. This should be 18. This should be 18. Now you can solve. You can solve it and multiply by 6. You can just add it. Add 10, 12, 18, 18 plus 2. Fine. 38, 34, 32. Fine. So the answer will be 876. Fine. 876 will be the answer. Can you please calculate it? Or let me calculate if you want. So let me calculate. Can you please calculate it? Is it correct? So we have, starting with 20 only. So it is nothing but 10 plus 12 plus 2 plus we have 18 plus we have 2 to 40. We have 38. 38 and 40 to 6. It is nothing but 34 plus 6 to 38. 6 to 38, my dear friend, we have 32. So 146 into 6. 146 into 6. So it is nothing but 146. This should be 146, okay? This is nothing but 146. So 146 into 6. So answer will be what? 876. 876. 876 will be the right answer for this one. I think it is clear. It is quite easy. Fine. Only like you need to do right calculation here. Fine. So only calculation mistake we have done, I think. Yeah. The answer will be what? 876. 146 into 6 only. Okay. It is easy question. Okay. Let me move to this question. Fine. So they're asking about, they have given the process arrival time and burst time, and they have asking you here, what is the average turnaround time? In millisecond, they're asking the average turnaround time. What will be the answer? Average turnaround time. It is quite easy question. FCFS you need to apply. So you need to make the Gantt chart here. See clearly. So process P1 at 0.0, my dear friend. Only we have one process and it is FCFS. FCFS is non-primitive. So P1 will be scheduled to the CPU till their burst time 0 to 8. Fine. So at 8, all the processes are arrived in the ready queue. So we have P2, P3, P4. So which process will be arrived first? It will be scheduled to the CPU. So P2 will be arrived first. So P2 will be scheduled to the CPU till their arrival time. So 8, 6, 14. After what we have, P3 will be arrived. So P3, what is the burst time? 4. It is nothing but 18. And then P4 will be arrived. It is nothing but 18 plus 2. It is nothing but 20. 20. So see, process is not waiting anywhere. Process is not idle in the CPU. If you see clearly, 8, 6, 14, 4, 18, 2, 20. If you count it, it is nothing but equal to this one. Fine. Because process is not waiting here in the CPU. It is not idle. Now they are interested about the average turnaround time. So average turnaround time, you know, it is nothing but completion time minus arrival time. So what is the P1 completion time? So I'm writing here TAT here. So completion time minus arrival time. What is the P1 completion time? P1 completion time is 8. So 8 minus 0 is nothing but 8. What is P2 completion time? P2 completion time is nothing but 14. 14 minus 0.6. 14 minus 0.6. Okay. Now, what is P3 completion time? 18. 18 minus 3.8. 18 minus 3.8. What about P4 completion time? 20 minus 4.4. 20 minus 4.4. 4.4. Fine. So this is nothing but turnaround time of P1, P2, P3 and P4. Fine. You please calculate it and add it and divide by number of process. We have 4 process. I think you will get 12.8. 12.8. Please try this one. If you have doubt, you can ask me. I'm not getting any reply. Please try to give the correct answer. Fine. Let me calculate it if you want. So yeah, we have 14 minus 0.6. So this is nothing but 13.4. And this is nothing but 18 minus 3.8. It is nothing but 14.2. 14.2. And this is nothing but 20 minus 4.4. So 20 minus 4.4. It is nothing but 15.6. Fine, 15.6. Fine. And you can add it. Let me add it. 15.6 plus 14.2 plus 13.4 plus 8 divide by, so it is nothing but 51.2 divided by 4. If you add this, it is nothing but 51.2 divided by 4. Divide by 4, it is nothing but 12.8. So 12.8 is the right answer for this one. Okay, 12.8. See, it will take time for the calculation. Fine, it is easy one, but yes, people do mistake in the calculation only. People do mistake in the calculation. Fine. Now the next question they are asking about in conservative two-phase locking protocol, a transaction. So conservative two-phase locking. So I think everyone know in conservative two-phase locking, my dear friend, we don't have growing phase. We have only shrinking phase. We have only shrinking phase. This is a lock point, and we have only what? Shrinking phase. We don't have growing phase. Means in conservative phase, my dear friend, what we do, my dear friend, before start of the execution, we lock all the data items. We lock all the data items. Either it is exclusive lock or shared lock. We lock all the shared lock, means read lock and write locks before start of the execution. So it is nothing but, see, should acquire all the locks at the beginning of the transaction. Right? Should require all the locks at the beginning of transaction. You can just remember like this. See here, we'll start from what? We'll start from shrinking phase here. Fine. All locks will be available here. Fine. All read lock, write lock will be available. Fine. We all lock. We lock all the data item. Either it is read lock or write lock. Fine. Read lock or write lock. Is that clear? Fine. Conservative 2PL. In conservative 2PL, is deadlock is possible? In conservative 2PL, can you please tell me? In conservative 2PL, is deadlock is possible? Answer is what? No. Deadlock is not possible. Deadlock is not possible, but it is not practically implementable. It is not practically implementable, my dear friend. Okay. See, I think we know, like we have 2PL, we have regress 2PL, we have, my dear friend, strict 2PL. Fine. But the problem is what? See, if you see in regress 2PL, what is the problem? Can you please tell me? Regress 2PL. So in regress 2PL, can you please tell me, my dear friend, what we do? What we do, my dear friend? Regress 2PL में क्या करते हैं कोई बताएगा? What is the difference between regress 2PL and strict 2PL? Anyone? Please reply. Regress 2PL और strict 2PL में क्या difference है? Yes. In regress we have no shrinking phase. And in strict, my dear friend, we have partial shrinking phase. We have partial shrinking phase. Fine. We have partial shrinking phase. Is that clear? I think yes. Okay, let me move to the next question. Context-free language are not closed under. What is the option? Which one is the correct? Can you please tell me? Context-free language are not closed under. Oh, very good, Shiv. Strict में हम exclusive lock को हम जब तक hold करके रखेंगे जब तक कोई भी operation आपका commit ना हो जाए. Fine. Okay, very good. So option is D for this one. So context-free language are not closed under what? Set difference, complement, and intersection. Okay, that is right. You should be remember this table. Fine. Context-free language. It is not closed under set difference. It is not closed under complement. It is not closed under intersection. So the answer will be what? All of these. All of these is the right answer. Okay. What about this one? Recursive enumerable language are not closed under. What is the answer? Can you please tell me? Recursive enumerable language are not closed under. What is the answer? Can you please reply fast? जल्दी से बताएं, फटाफट, जल्दी फटाफट बताएं, प्लीज रिप्लाई फास्ट. Recursive enumerable language are not closed under. TUC is not in your syllabus. Okay. So answer is what? Both A and B. This one is also both A and B. Okay. So we'll skip this, no problem. But yeah, they have asked in previous NIELIT exam. So recursive enumerable language are not closed under A and B, my dear friend. A and B. Both A and B. Okay. Okay, can you please try this one? Table employee has 10 records. 10 records. It has non-null salary column, which is also unique. The SQL statement. If you run this query, my dear friend, what will be the output they are asking? What will be the output? Can you please reply? What will be the output? Okay, these all are NIELIT. Some mixed questions are there. Some NIELIT PYQs and some new questions are there. But yes, make sure like in next class you will get some new stuff also. And like they will ask only easy question. I just told you 10 minutes before also they will ask easy question only. They will not ask very tough question. Straightforward question they will ask. So this is the query. This is the sub query, like nested query you see here. So query inside query. So first I think inner query will run and the result of inner query will be used by the outer query. The result of inner query will be used by the outer query. Fine. And they have written here all. And they are telling, see here, all salary are distinct. All salary are distinct, my dear friend. Fine. All tell record. The employee has 10 records and it has non-salary column. It has non-null. Non-null means there is no null in salary column, which is also unique, and all are unique, my dear friend. Let's suppose salary column is nothing but this is salary. And this is nothing but, let's suppose 10, 20, 30, 40, 50, 60, 70, 80, 90, 90, 100, let's suppose. So my dear friend, see clearly, select salary from employee. So you select salary from employee, okay? And my dear friend, they are telling where salary greater than all salary. So can anyone greater than all salary? No one, my dear friend. Greater than all they are writing. So it is nothing but, it will select what? No records. So answer will be what? 0. Answer will be what? 0. So 0 will be the answer. 0 will be the answer. Are you getting my point? 0 will be the answer. Can you please tell me? 0 will be the answer for this one. Yeah, D for Delhi is the right answer for this one. Okay. So I think, yes, I think you're telling graph theory is not in your syllabus, so you can skip this question as of now. This question is easy only, fine, based on your first theorem of graph theory. Fine. First theorem of graph theory, like it is nothing but sum of degree of vertices is 2 into number of edges. And in tree, the edges will be n minus 1. So edges will be here 9. Now you can just use the formula and you are able to solve the problem. Okay. So I'm skipping now. I'm skipping this one also. This is nothing but this one is nothing but minimum degree formula. Fine. This is also easy one. Fine. And they are asking about maximum possible value of n, maximum possible value of v. Fine. It is also easy. For this one, the question, okay, for the previous one, maybe 18 is the answer. And for this one, the answer will be 16. 16, you can try. Okay. And the formula will be 2e by v. This is the minimum degree. And this is nothing but number of edges. This is nothing but number of vertex. So they are asking about number of vertex here. You can try this question. Okay. Which of the following statement about parser is not correct? Not correct. Can you please tell me? Not correct. Canonical LR is more powerful than SLR? CLR. Is CLR is more powerful than SLR? Yes, this is true. This is true. Is SLR is more powerful than LALR? No, this is false. SLR is more powerful than canonical LR? No. So what is the answer? Answer is A only. Answer is what? A only for this one. Fine. I think most powerful parser is what? CLR. CLR. Most powerful parser is what? CLR. Most powerful parser is CLR, my dear friend. After that, what we have? We have what? LALR. After LALR, what we have, my dear friend? SLR. Then what we have? What? LR. Fine. You know this one. So most powerful parser is what? Canonical LR. After then we have LALR. After then we have SLR. Then what we have? LR. After then we have LL1, top-down parser. Bottom-up parser is more powerful than top-down parser. Everyone know. In bottom-up parser, CLR is most powerful parser. CLR is most powerful parser. Okay. In this question, can you please tell me what is the follow of Q? Follow of Q they are asking. So I told you how to find follow. Whenever they in question they will ask follow, jump right hand side. Jump right hand side. Jump right hand side. Find first of find first of find first of that after Q. After Q, whatever is there, find first of that. See clearly. Jump right hand side after Q, whatever is there, find first of that. What is first of R? See, after Q, what is there? RS. RS, my dear friend. In RS, what is first? What is first R? So what is first of R, my dear friend? Can you please tell me? First of R is nothing but W and null. W and null. If it is null, my dear friend, it means R is over. R is over. It means union of first of S. Union of first of S. Can you please tell me what is first of S? Y. First of S is nothing but Y. Y, my dear friend. So what is follow of R? Follow of R is nothing but C is the option. W comma Y is the right option for this one. See, whenever they will ask you follow, jump right hand side. They are asking about follow of Q. So follow of Q, after Q, whatever is there, find first of that. So after Q, whatever is there, find first of that. What is first of RS? First of RS is nothing but first of R. What is first of R? W and null. If it is null, if R is null, it will give chance to S. Union first of S. What is first of S? Y, my dear friend. First of S is nothing but Y. Y. So that's why this is the answer. Okay. Now this question, which of the following is true, my dear friend? Every relation in 3NF is also in BCNF? Yes. The lower normal form, every relation in 3NF. No, they are telling every relation in 3NF is also in BCNF. No, this is false. Every relation in BCNF is also in 3NF. Fine. Higher normal form implied lower normal form. Lower normal form does not imply higher normal form. They are telling every relation in 3NF is also in BCNF. No. No, man, this is false. This is absolutely false. Fine. A relation R is in 3NF if every non-prime attribute of R, is fully functionally dependent on the key of R. Key of R, my dear friend. Can you please tell me? No, this is also false. This is also false. They are telling here a relation R is in 3NF if every non-prime attribute of R is fully functionally dependent on every key of R. It is nothing but. Okay, sorry. I will give you time. Okay, you can please try to give the answer. Okay, we are running out of time. That's why. No problem. You can give the answer. What is the answer for this one? Can you please reply? For this one, what is the answer? Which of the following is true? Okay, option C for this. Yes. Every relation is BCNF is in third NF. Yes, this one is true. This one is true. No relation can be both in BCNF and third NF. No, this is false. A relation can be in BCNF and third NF. Yes. So option C is the right answer. Higher normal form implied lower normal form. If a relation is in BCNF, definitely it is in third NF, second NF, and first NF. Fine. But lower normal form does not imply higher normal form. Okay. See, in first option they are telling every relation is third NF. It is also in BCNF. No, this is wrong, my dear friend. This is wrong. Absolutely wrong. Fine. The second one, my dear friend, it is also wrong because this is nothing but they are talking about fully functional dependency. It is nothing but they are talking about for second normal form. That's why it is incorrect. Third one, they are telling yes, it is correct only if it is in BCNF, it is in third NF, it is in second NF also, first NF also. And no relation can be in both BCNF and third NF. This is wrong. Fine. A relation can be in BCNF and third, because if in BCNF, it should be what? It should be in all other normal form. Okay. Okay, can you please try this question? I'm waiting for the answer. Consider the relational schema R, A, B, C, D with following FD set A goes to C, B goes to D, A goes to D. Identify the highest normal form satisfying the relation. Can you please tell me what is the answer? Okay, someone telling D. Okay, let me try this. See, so they have given the FD. So you need to find the candidate key. Okay, so you need to find the candidate key. What is the candidate key for this relation? Can you please tell me what is the candidate key? See clearly, D is in right hand side, fine, and C is also in right hand side. A and B is not right hand side. A and B. So A and B will definitely part of the candidate key. See clearly here, whatever the attributes, fine, if they are not in right hand side, they will definitely part of the candidate key. So see D in right hand side. So I am just removing D from here, and I am removing C also. And in here they have also given E. Okay, but in relation E is not there. In relation E is not there. So let me just solve this question here. In relation A, see clearly E is not there. See, they have not mentioned E here. A, B, C, D, and E. Let me try here. What I am trying to say, my dear friend, see clearly. You need to observe carefully this question. Fine, this is good question only. Okay, so no E is here. So this FD is what? This FD is what? Irrelevant to us. See, because no E is here. From AE we are determining D. So this FD is what? Irrelevant to us. And see, so A goes to CE. So this is what? Single value non-trivial FD. So I can write here A goes to C. A goes to E is irrelevant to us according to this schema, because we have only A, B, C, D here. So here we have only A to C, and here we have only B to D. Are you getting my point? We have only two FD. And the relation what we have? Relation we have A, B, C, D. Because see, in the relational schema, E is not given. In the relational schema, E is not given. So if E is not given, there is no meaning of E in the FD. Fine. So I have removed this one, because from AE I am determining D. From not A I am determining D. So this FD is irrelevant. Fine. Irrelevant. So from combinedly A we are determining D. So this is irrelevant FD for us. A goes to E also irrelevant FD for us, because we can break the right hand attribute. We cannot break the left hand attribute, you know. So this is the FD as of now. So what is the key? Key is AB. So AB is the key. Fine. AB is the key, my dear friend. AB is the key. Now AB is the key, my dear friend. Now you see clearly here, this is nothing but partial dependency, because A is the proper subset of AB, and C is the non-prime attribute here. C is the non-prime attribute here. Fine. So this is nothing but partial dependency. This is nothing but also partial dependency, my dear friend. This is nothing but partial dependency. Can you please tell me? This is nothing but partial dependency. So the highest normal form is nothing but first normal form. D is the right answer. Okay, might be they will tell you also, let's suppose in the question, they will tell you the following relation A, B, C, D, and the FD is A to C and B to D, and it is not in second normal form. It is not in second normal form. Fine. So how many minimum number of tables are required to convert this relation into second normal form? Kitna minimum table lagega? Can you please tell me? How many minimum tables are required? How many minimum tables are required to convert this one into the second normal form? Kitna table lagega? How many tables you can do it? In how many tables you can do it? Maybe they will ask in the gate. Fine. Not in gate, in your NIELIT examination also. Fine. I'm waiting for the response. Can you do in two table, my dear friend? Not possible. Doing in two table is not possible. If you do in two table, my dear friend, it will be a lossy join decomposition. If you separate for A and C and B and D, my dear friend, B and D, my dear friend, see, it will be a lossy join. It is lossy join. It is not lossless join, my dear friend. Fine. Because see, in AC and BD, there is no common attribute. So how you can merge them? You are not able to merge them. It is a lossy decomposition. Fine. Even though see clearly here A is the super key, here B is the super key, no problem. But my dear friend, it is not in second normal form. And already, you know, in the very first question I told you, second normal form is lossless plus dependency preserving. Fine. See clearly. So what we need to do? We need to make one more table. See, whenever problem is there, here problem is there, make in one table. Here problem is there, make in one table. So what is left? See, C and D is gone. C and D is gone. Right hand side is gone. Now we have left with A and B. A and B. Fine, A and B. Now for this one, A is the key. For this one, what B is the key. And you know, this A is referring to this one. And this B is referring to this one. Now you can merge them. Now you can merge them, my dear friend. Now you can merge this one A, B, C. Fine. And the result of this one, you can merge with this one. So now it is what? Lossless also and dependency preserving also. Here we don't have any non-trivial FD. Fine. In here AB, we don't have any non-trivial FD. Fine. I think this one is clear. So how many tables are required? 3 tables are required, and it is lossless also, it is dependency preserving also. Even for 3NF also, 2 tables are required. Even for BCNF also, 3 tables are required. For BCNF also, 3 tables are required. Is that clear? So here we have 3 tables. 3 tables, not 2 tables, my dear friend. 3 tables, and it is lossless. It is lossless, and it is dependency preserving. Fine, it is dependency preserving. 3 tables are required for 2NF also, and for 3NF also, and for BCNF also. Fine, is that clear? Please reply. Okay. You are not able to do with 2 tables. So might be they will ask you. It is easy one, it is not tough one. Fine, already I have discussed in the class. Okay. So which of the following statement is false? They are asking about. LR0 grammar and SLR1 grammar are equivalent, and LR1 grammar are subset of LLR1 grammar. Okay, so what we have, see, I am just giving you some question. From this question onwards, I will take in the next class. Fine. So you can solve this question because we have so many questions as of now. So I will start from here only from the next class. Fine. So we have this question. You can try this question also. Fine. You can try this question also. So we have more question. Discrete question you can skip. As of now, I can share in the Telegram link also. Fine. So we have more question on CN and DBMS. Fine. So we have more question here. And from COA also we have more question. Fine. So in next class we will see this. Next class we'll see this, my dear friend, on day after tomorrow. Not tomorrow. Tomorrow is break. Tomorrow is Wednesday. So we have a class on Thursday and we have a class on Friday. So Thursday, Friday we have a regular class 9 to 10 p.m. Fine. Same time. NIELIT question we'll solve, and like more good question we'll try to solve with the concept also. Fine. If you are lagging with some concept, I will try to give you. Fine. And this is a test series, my dear friend. This is very important for GATE aspirants, even for Telegram link. आप चेक कर सकते हैं, आप जिस डिस्क्रिप्शन के अंदर दिया हुआ है, फाइन, वहां से you can join my Telegram link. Fine. You can join my Telegram link. I will share this PDF there so that you are able to solve some problems. And you can meet me on 9 p.m. on Thursday 9 p.m. same time, and we'll try to solve more questions. So yeah, test series is very much important, my dear friend. Please join the test series. And scholarship test program on 15th of October, and this is 9 a.m. to 9 p.m. and 11th of October, my dear friend. I think sir has already taken the class. Today is I think 11 only, if I'm not wrong, 10. So tomorrow there will be a class on 7:30 p.m. This is important. Those who want to prepare for GATE 2024, this class will take by Abhinav Negi sir. And yeah, Vision Crash Course GATE has been already started. If you want, you can join this course as soon as possible. And this is my Telegram link. This is my Telegram link, my dear friend. You can join this Telegram link. Fine. And please like and share and subscribe it अगर आपने subscribe नहीं किया. And you can also join the BYJU app, where I will take after this one I will take some classes. Like we have a class day after tomorrow, and the next day, like Friday, and Monday, Tuesday, Wednesday on YouTube, followed by I will take NIELIT class on BYJU app. So BYJU app का भी link दिया हुआ है. Fine. वहाँ पे जाके आप BYJU app install कर सकते हैं, and it will be free class for NIELIT students, those who are preparing for NIELIT exam. I will take free class on BYJU app also from next week. Fine. So you can join this Telegram channel so that you will get the notification of my class also, and you can install the BYJU app also. Fine. So that you are able to see my classes, those who are preparing for NIELIT and GATE. Fine. So thank you so much. I will see you tomorrow, not tomorrow, day after tomorrow. And please try to give more effort, because बहुत कम दिन बचे हुए हैं NIELIT exam के लिए. Fine. So do your revision and I will on next day I will take some good question in front of you, so that like you will be get motivated also, and you do your preparation in a correct direction, in a right direction. Thank you so much. We'll see you.